Number 1. Which equation represents the line that passes through the point negative 2, 2 and is parallel to y equals 1 half x plus 8? Okay, so there are two things that you need to remember. One, that parallel lines have same slope. So let's talk about the slope of the given equation before we get into it. So slope is the coefficient of x, which is 1 half. So any line that is parallel to this equation has to have the same slope of 1 half. So let's check out the coefficients of our choices. The coefficient of x for first one is 1 half. So this could be our answer. Choice 3 is also 1 half. But look at choices 2 and 4. The coefficient of x, or our slope, is not 1 half. So it cannot be this answer choice. So 2 is not your answer and 4 is not. So now what do? I can put this equation y equals 1 half into y1 on my calculator, look up the table, and when you go to your table and check for the point negative 2, 2, is that point on the table? So if I look at the table, I do have negative 2 as my x coordinate, but my corresponding y coordinate is negative 1. So this is not the right answer. So it's choice 3 basically. We're left with that. Look at choice 3. Your x coordinate is negative 2 and your y coordinate is 2. So it is choice 3.
Question number 2. In the diagram below, triangle ADE is the image of triangle ABC after a reflection over the line AC, followed by a dilation with a scale factor of AE over AC centered at point A. Which statement must be true? Okay, so this is a dilation. Dilations preserve angle measure. And all these answers are talking about angle measure. So dilations preserve angle measure, therefore choices 3 and 4 are dead wrong. They are manipulating them. So these are manipulations. We don't want that at all. We need either choice 1 or choice 2. So let's look for the ones that are corresponding to each other. The measure of angle BAC is equal to the measure of angle AED. Okay, well those are not corresponding to each other because triangle ABC is similar to triangle ADE. This angle over here is corresponding to the angle next to it. So therefore, it cannot be choice 1, it has to be choice 2. The measure of angle ABC is congruent or equal to the measure of angle ADE. So that's why it is going to be choice 2. Moving on to question 3. Given that triangle ABC is congruent to triangle DEF, which statement is not always true? So immediately you have to think to yourself, well, I have to draw a figure. I need to draw two triangles that are congruent to each other. So this triangle and this triangle. Triangle ABC and triangle DEF. Which statement is not always true? Well, BC is congruent to DF. Is that not always true? Yes, it is. That's not true. I mean, it could be true, but it's not always true because those are not corresponding to each other. BC is not corresponding to DF. BC is corresponding to EF, not DF. So therefore, choice 1 is your answer. Moving on to question 4. In the diagram below, DE, DF, and EF are mid-segments of triangle ABC. The perimeter of quadrilateral ADEF is equivalent to what? So we need to figure out what the perimeter of this quadrilateral is. But we do know a couple things based off of the given information. These are all mid-segments. So this is a midpoint. This is a midpoint. This is a midpoint. Mid-segments are drawn to its midpoint. Okay? Now a midpoint divides a segment into two congruent parts. So the length of AD, by algebraic representation, the length of AD is actually equivalent to 1/2 the length of AB. Same thing for AF. AF is 1/2 the length of, in this case, AC, because F is a midpoint. Now, mid-segments are also parallel to its base. So if this line AF is 1/2 the length of AC, DE is also 1/2 the length of AC. And DA is 1/2 the length of AB, therefore EF is 1/2 the length of AB. Okay? And the reason why I'm telling you AC and AB in terms of AC and AB is that the answers are in terms of AC and AB. The perimeter of this quadrilateral, well, perimeter means add up all the sides. So take 1/2 of AB plus 1/2 of AB plus 1/2 of AC plus 1/2 of AC. 1/2 of AB plus 1/2 of AB is AB, plus 1/2 of AC and 1/2 of AC is plus AC. So that's why it is going to be choice 4 for this question. Number 5. In the diagram below, if triangle ABE is congruent to triangle CDF and AEFC are drawn, then it could be proven that quadrilateral ABCD is a what? Well, if we have this information that these two triangles are congruent, we know a couple things. The opposite sides are the opposite sides in this quadrilateral are congruent because of CPCTC. These angles are congruent by CPCTC. These angles are congruent. These angles are congruent, and these sides are congruent. Now, since these two angles right here are congruent, and that forms a Z, making alternate interior angles, these sides over here, BA, is parallel to CD. And look at this, ladies and gentlemen. If you have one pair of congruent and parallel sides, then this quadrilateral must be a parallelogram. We don't have enough information to prove this to be a square, a rhombus, or a rectangle. All right, moving on to question number 6. Under which transformation would triangle A prime, B prime, C prime, the image of triangle ABC, not be congruent to triangle ABC? The one that we're looking for is not congruent, so therefore we're looking for the transformation that changes size and changes distance and congruency. So a reflection, no. Rotation, no. Translation, no. All of these are rigid motions. All of these are rigid motions. So rigid motions preserve distance and congruency. Your dilation is the answer, choice 4, because a dilation is not a rigid motion. Okay? And that's why it is going to be choice 4. Moving on to question number 7. The diagram below shows two similar triangles. If the tangent of theta is 3/7, what is the value of x to the nearest tenth? So a couple things. They tell us that they're similar triangles. That tells us that similar triangles are in proportion. And we are going to be doing this in a moment here. Now, the tangent of theta, well, you need to know that tan of anything is the opposite over the adjacent. And this over here is your hypotenuse. So the opposite side of theta is 3 and the adjacent side is 7. We're not using this because that's your hypotenuse. Now, these two triangles are similar to each other because they tell us that. Now, similar triangles are proportions, so we could solve for x by using, again, similar triangle proportions. So we could say 3/7 is equal to 2.4 over x. Now we could cross multiply these. 3x is equal to, let's see, 2.4 times 7. If you type that into your calculator, by the way, I use a TI Inspire. It's a great calculator. You could purchase this off of my website. It's just a link to Amazon. I'm not making any money off of it. 16.8, no, I'm sorry, 12.4, no, 2.4 times 7, and that's going to be 16.8. So 3x is equal to 16.8, and now we are going to divide by 3 on both sides. Divide by 3, and we get 5.6 as our answer. So x is equal to 5.6, which is going to be choice 2. All right, moving on to question 8. This is one heck of a question. In my opinion, this is the hardest question on the whole test. I'm telling you. I want to explain this in full detail. A farmer has 64 feet of fence to enclose a rectangular vegetable garden. Which dimensions would result in the biggest area for this garden? Okay. Let's take a look at choice 1. The length and the width are equal. that means that the length is x and the width is x. I don't know what the length and the width are, so I call those x. A farmer has 64 feet of fence to use. That 64 is represented by perimeter. Perimeter is the addition of all the sides of a figure. Area is equal to length times width, in this case because it's a square. So, how do we find the perimeter of choice 1? Well, the perimeter is you're adding x plus x plus x plus x is equal to 64. If you keep adding these x's, you get 4x is equal to 64. Divide by 4 on both sides, and you get x is equal to 16. But what in the world does this tell us? That 16 tells you that the length and the width are both 16. So now, we just found the perimeter. Now we need to find the area. The area of a square is length times width. So the area of this is 16 times 16, which is equal to 256 when you plug it into the calculator. It's asking you to result in the biggest area. So the area for this is 256. Okay, let's keep going with this. Let's try number 2. The length is 2 more than the width. So therefore, your length is x plus 2 and your width is just x. So let's try to find the perimeter. Well, the perimeter is x plus 2 plus x plus 2 plus x plus x is equal to 64 feet of fencing. X plus x plus x plus x, that's 4x, plus 2, which is 4, is equal to 64. Now we are going to subtract the 4 on both sides, and we get 4x is equal to 60. Divide by 4 on both sides, and then you get x is equal to, let's see, I believe that's 15. 60 divided by 4, that's 15. Great. Now, that's the length of the width, and the length is going to be 17. So the length is 17, the width is 15. Now the area, again, the area of this time is a rectangle. The area of a rectangle is still length times width. So the area is equal to 17 times 15. When you take 17 times 15 and you plug it in to your calculator, you get 255. So the area of choice 2 is going to be 255. Okay? Now, I am going to tell you a relationship. If you keep increasing the length by 4, 6, 8, 10, and it doesn't matter how much you keep increasing the length, the area is going to decrease. And I'll tell you right now that the area of choices 3 and 4 are less than 256. So if you don't believe me, just do the same process for choices 3 and 4, but I'll tell you right now that the answer is going to be choice 1. That, in my opinion, was definitely quite of a challenging question for a multiple choice, and it required a lot of work. All right, moving on to question 9. The diagram shows rectangle ABCD with diagonal BD. What is the perimeter of rectangle ABCD to the nearest tenth? So what you have to say to yourself is say, hey, wait a minute, I need to draw my little stick figure, and I need to solve for one of these sides. The problem is we don't have anything, nothing. But we do have the hypotenuse. So we could solve for DC using trigonometry, right? We could say, all right, we're going to use SOHCAHTOA because we need to find the perimeter of this whole thing. So that's your opposite. And since this is a rectangle and that's a right angle, this is your hypotenuse. So we are using sine. So the sine of 30 degrees is equal to the opposite, which is x, over the hypotenuse, which is 12. And you put that over 1. Now we cross multiply. So we get 12 sine of 30 is equal to x. When you plug that into your calculator, 12 sine of 30, that will give you a result of 6. And there it is. So x is equal to 6. So I'm going to get rid of this opposite side and all these other things in the middle. And I'm going to say that this is 6, and therefore this is 6 over here. Now, you need to solve for the length of BC. I'm going to call that y. Ladies and gentlemen, this is a right triangle. It's a right triangle, and if we're given two sides of a right triangle, we could solve for the third by using the Pythagorean theorem. So that's exactly what I'm going to do. I'm going to say a squared plus b squared is equal to c squared. Let's go ahead and solve for it. So we get a squared, a squared plus 6 squared equals 12 squared. I should have really called that a. Sorry about that. I'm changing that y to an a. A squared plus 36 is equal to 144. Subtract the 36 on both sides. You get a squared is equal to 108. And then you take the square root of both sides. Now, when you take the square root of 108, you have to think of, okay, well, what are the two numbers that go into 108 with one of them being the highest perfect square? Those two numbers are going to be 36 and 3. The square root of 36 is 6. Add on the radical 3, attach that on. So that is a, 6 radical 3. And remember that its opposite side is also 6 radical 3. Now, the perimeter is the addition of all these sides. So I'm taking 6 plus 6 radical 3 plus 6 radical 3. When you type that into your calculator, you get 6 plus 6 radical 3 plus 6 radical 3. And that is going to yields an answer of 32.8 when you round it. 32.8. Choice 2 is the answer to number 9. Again, a lot of work for a simple part 1 question. Moving on to number 10. Identify which sequence of transformations could map pentagon A, B, C, D, E onto pentagon A double prime, B double prime, C double prime, D double prime, E double prime, as shown below. So we are going from this to this. Well, you could just do a basic line reflection. You could reflect over line L. I'm going to call that line L. And if you reflect over this line, you get an answer like this. Let me just draw it to the very best of my ability. Yeah, that looks pretty good. So this is A prime, B prime, C prime, D prime, E prime. So it's a basic line reflection, and then it's followed by a simple translation to the right. So I'm looking for a line reflection followed by a translation. That is going to be choice 3 for question number 10. All right, moving on to number 11. A solid metal prism has a rectangular base with sides of 4 inches and 6 inches and a height of 4 inches. A hole in the shape of a cylinder with a radius of 1 inch is drilled through the entire length of the rectangular prism. What is the approximate volume of the remaining solid in cubic inches? In other words, it's asking you, say, hey, take the volume of the prism, which is just a box. That is all. I don't know what that was. That was disgusting. It's taking the volume of the box minus the volume of the cylinder. Well, the volume of a box is just length times width times height. The volume of a cylinder is 1/3 pi r squared times the height. You can find the volume of a cylinder formula off of your reference sheet. Length times width times height is just one of those things that you have to memorize. But technically, it is given to you on your reference sheet as capital B times height. I just say length times width times height. It's so much easier to say. So the volume of the rectangular prism is length times width times height. That is going to be 4 times 4 times 6. And the volume of the cylinder is pi r squared times the height. That's going to be pi times the radius. Now, the radius they tell us is 1. So 1 squared times the height of 6. Ladies and gentlemen, if you stand this block up, or if you stand this box up, this is the height of the cylinder, not the 4. So, we get these. So, I'm going to get these results. So, 4 times 4 times 6, that gives us 96. Oops. 96. And this will give us approximately, let's see, pi times 6. It's really pi times 6. 1 is there, but we don't really need it. So that's going to be 18.8. So we take 96 minus 18.8 to find the volume of the remaining wood. The remaining solid is 96 minus 18.8. When you plug that into your calculator, you get 77.1. So that's approximately equal to 77, which is going to be choice 2. And that, I keep pressing, oh God, I keep pressing this. And that is how you do question number 11. All right, last question of the video. Given the right triangle in the diagram below, what is the value of x to the nearest foot? So you're going to draw your little stick figure man, or whoever, and you are going to say, all right, 14 is your adjacent side, x is your hypotenuse. Your reason is it is across from your right angle, that's why it's the hypotenuse, and the adjacent side is next to it. So we are using, again, SOHCAHTOA. So if we have the adjacent and the hypotenuse, we are using cosine. So the cosine of some angle is equal to the adjacent over the hypotenuse. So the cosine of 40 is equal to the adjacent, which is 14, over the hypotenuse, which is x. We are then going to cross multiply this information. Put that over 1, we get x cosine 40 is equal to 14, divided by cosine of 40 on both sides. And we get, let's see, control division, 14 over the cosine of 40, and we get 18.27. That's about 18.3. Doesn't matter. They're asking you for the nearest foot. That is equal to 18. So x is approximately equal to 18.